Alright, welcome back. We're going to be doing a couple of worked examples of taking the derivative using the limit definition of the derivative. So here's a question you might have to do on a test, which is use the limit definition of the derivative to compute f prime of x for f of x equals x squared plus x. So you probably remember this. The limit definition of the derivative is f prime of x is the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. And in order to compute this, you of course have to know how to do basic limits and how to work with functional notation. So if you don't remember how to do these things, stop now, go back and watch the right videos, and then come back and watch this. So the first step is to write out the function that you're going to take the derivative of. In this case, f of x is x squared plus x. And in order to compute the derivative, write out the limit definition. You just copy this each and every time you take the derivative when you have to use the limit definition. Now, under here, I'm just going to do a little scratch work. F of x plus h is x plus h squared plus x plus h, because f of x is x squared plus x. And I've squared x plus h and added it to x plus h. And so I'm going to replace f of x plus h with my computation, and I'm going to replace f of x with x squared plus x. Notice over here I've used parentheses around x squared plus x. That's because I'm subtracting all of it. I've canceled out the things which are repeated, so x squared minus x squared cancels, and x minus x cancels, and all I'm left with is 2xh plus h squared plus h, all divided by h, inside of my limit. So I rewrite this as the limit as h goes to 0 of h times 2x plus h plus 1 all over h. Since all three terms on the top in the previous line have h's, I can pull an h out from each. Now, since h is going to 0, but never 0, we can cancel the h up top with the h below. And when we do that, we're left with the limit as h goes to 0 of 2x plus h plus 1. The only appearance of h is here in the center between 2x and 1, and as we let h go to 0, that's just going to disappear. And so what we're left with is 2x plus 1. Now, you've noticed on each and every line I've written the limit, until I was able to let h actually go to 0, and when I did that, I stopped writing the limit sign. And so you must always write the limit until you actually get a chance to calculate it. And ultimately what we see is that f prime of x equals what's left, which is 2x plus 1. One more example. Use the limit definition to compute f prime of x for f of x equals x over x minus 1. So, again, every time you do this, write the limit definition. The limit definition is f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. Now, I'm going to do some more scratch work over here. F of x plus h is x plus h over x plus h minus 1. And if I were to subtract f of x plus h minus f of x, what I'm going to get is the fraction I just computed, which is x plus h over x plus h minus 1 minus x over x minus 1. And if you get common denominators in order to subtract them, you get x plus h times x minus 1 minus x times x plus h minus 1 all over x plus h minus 1 times x minus 1. And if you go ahead and multiply everything out, you get what's there, which is x squared plus xh minus x minus h minus x squared plus xh minus x all over x plus h, x plus h minus 1 times x minus 1. Now I've canceled everything that can cancel, and all that's left up top is negative h. On bottom we'll still have x plus h minus 1 times x minus 1. Now, I've only computed f of x plus h minus f of x. The actual limit has an h beneath this. And so, look at the purple. If I was to need an h beneath that in the denominator of a fraction, I have to multiply the thing on the right by 1 over h, which gives me an h everywhere underneath. So as I go back up top and actually start working on the limit again, what I get is the limit as h goes to 0 of negative h over h times x plus h minus 1 times x minus 1. Now, since I have an h up top as well as down below, those h's are going to cancel as long as h isn't 0. Since h is going to 0 in the limit, h is never actually 0, and thus they can cancel. And I'm left with the limit as h goes to 0 of negative 1 over x plus h minus 1 times x minus 1. Now, since this function doesn't have a problem as h goes to 0, we can in fact actually now just plug it in. And what we get is negative 1 over x minus 1 squared. And so the derivative of x over x minus 1 is negative 1 over x minus 1 squared. And that's it. Go ahead, practice taking a couple more derivatives, and watch the next video. I'll talk to you soon.